Good evening, everybody. I am Judy Black. I'm president of the RASC Halifax Center, as well as I was the chair this past year of the 2020 Nova East Star Party, which, as many of you know, didn't happen as a physical event, but it did transform into a virtual one. And as Dave pointed out a moment ago, this is being recorded, and the video will be on our center's YouTube channel, and we'll post that for people. We'll let National know too how to access it. This is the first of 6 in the series that we call 2020 Nova East, the COVID-19 edition. Because we couldn't get our speakers to be with us in person, they've graciously agreed to be with us virtually. And so between now and September the 8th, every Tuesday night at 7 p.m. Atlantic, 6 p.m. Eastern, if you're more attuned to that time. Please join us for each of the sessions. You can go to our website, which is novaeast.rasc.ca for more information about the speaker series and how you can register for it. You can also find out information about our center's astro imaging contest, but please take note, it is only for residents of Nova Scotia and for members of our center. So those of you from other provinces, I apologize. But anyways, the criteria is on our website, as well as, please note, the submission dates are from August 21st to midnight, September 11, and then we'll go from the winners will be announced in October. One of the things that is always part of our Star Party are t-shirts, and this year is no exception, despite the fact we aren't meeting in person. And I'll have to stand up for this. But this is our t-shirt. Now it can be any color that you so choose. I ordered mine in blue, but as you can see, the original title of our Star Party was Planets. And if the planets look a little lopsided, it's only because that is the location of the planets as they would have been had we held our event on the weekend of August 21 to 23. So if you'd like to have a t-shirt with this, you're certainly welcome to order one. And again, you can go to our website to do that. And you can there's lots more going on in our center, and you can certainly go to our center website, which is halifax.rasc.ca, such as our next members meeting, which is not until September 12th at 1 p.m. Atlantic, 12 p.m. Eastern. And our very first guest for the fall we're really excited about is Nicole Motilero, and many of you should know who she is. And so we're quite excited about that. I'll post both the Nova East site and our center site on the chat list, so if you'd like to access those, you can. In the meantime, I'll hand the session over now to Dave Chapman. For those of you that don't know this dear soul, he has a long history of service with both the national body as well as us provincially, or at our center here in Halifax, in many capacities. Everything from president to vice presidents to whatever, secretaries, etc. And he was recently awarded the Fellow of the RASC this past spring. He currently serves as our center's observing chair and is the member of our Nova East Planning Committee. He's the one that actually organized our speakers for this series. So thanks, Dave. Thanks to our speakers who have agreed. And without further ado, I will let Dave and Kathy take it away.
Well, thanks very much, Judy. Happy to be here. I guess I would have been the chair of the sessions at Nova East, so I thought it was fitting that I moderate these online sessions. You shouldn't see too much of me. One thing I would like to ask Judy, or maybe I'll just say it. If there's anybody out there who is basically just watching, would you please mute your microphone? Because I'm hearing a lot of background noise.
Whoop, Dave, hang on. I muted you too. Kathy, I've unmuted you. Dave, can you handle remute your thing?
Oh, I'm unmuted now. Okay, thanks. Okay, we dealt with that. No background noise. It doesn't mean people can't jump in and ask questions. That's not the point. The point is that if you don't have anything to say, please mute your microphone. And now it's nice and quiet. Great. So it's my great pleasure to introduce Kathy as our first speaker. There is a biography online, but I ignored it. I just talked to her the other night and took some notes. So anyway, Kathy came to us from way out west in 2013 to Nova Scotia. And she says her origin was in Calgary, and she got interested in astronomy by observing Hale-Bopp, which is interesting because that's the last naked eye comet that I recall seeing before Neowise came along. So kind of everything came full circle. She settled down eventually in Halls Harbor, 2015, and relocated her observatory there. And she's been doing amazing work doing astrophotography there. She got Picture of the Week in Sky News in 2018. Her Messier 13 picture was chosen as one of the, or maybe the favorite picture from the RASC 150th anniversary. And also in 2018, that same picture was not only the deep sky winner in the deep sky category, but was also the People's Choice. So she obviously knows what she's doing. And Kathy, we don't want to see that picture anymore. I'm just kidding. Well, anyhow, with that, today Kathy is going to talk about processing astro images for beginners. So this can be a daunting topic, and you can see when people talk about it, it seems like they're talking a foreign language. Hopefully Kathy's going to break it all down for the beginner to help you get started with processing your photos in an elementary way, just to get going. And so Kathy's going to give a little talk. I don't know how long that's going to be, maybe something like 20 minutes. And then she's actually going to do a live demo. We rehearsed this the other night and it works fine. So, so Kathy, take it away.
Thanks, Dave. My name is Kathy Walker. I've been into astronomy all my life, since before I can even remember. Member of the Calgary Center at one time, and I've been an unattached member, and I've been a member of the Halifax Center since 2013, and I've been doing astrophotography since 2010. So I've got about 10 years of experience. There's lots of people better than me, but I think I've got a knack for explaining things to beginners. So let's give it a try. There we go. Okay, this is going to be a very basic presentation. So just so you know what to expect, I'm going to be introducing some of the basic concepts in image processing. If you've already got images that you've been processing and you just want to improve your technique, you might find this too basic for you. On the other hand, if you've got some of the beginner questions that I've heard, like I can hardly see anything in my image, why isn't there more contrast, why is there no color, why is there too much color? If you've got questions like that, this might be the presentation for you. So I'm not going to focus on any specific software package. I'm going to try and keep it as generic as possible. Obviously, I have to use something for the examples. So I'm going to be using Deep Sky Stacker and GIMP, which is a graphics program. Both are free. They're fairly simple. Lots of people use them. There's lots of support on the internet. But I'm not going to get into the details of the software. I assume you can learn that from somebody else or somewhere else. This is about what to do with it. And I'm going to be using beginning data. As Dave pointed out, I got very lucky with one particular image of Messier 13. I'm not going to be using that image. I'm not going to be using anything recent. My examples are taken from my first year of astrophotography. So very beginning data, typical of what you might get with your own equipment. So when the objective of this presentation is when you research processing on the web, some of the terms will be familiar. I'm not expecting anybody to take notes. There's not going to be a test at the end, but hopefully when you go online and Google some technique, you can remember, oh yeah, Kathy talked about that. So what I'm going to talk about is first of all stacking and image calibration. In stacking and calibration, you provide the data. So it's up to you to take your pictures, take your calibration frames, but the software does most of the work. It's really a matter of just loading all your data images into the software, hit go, go away, have a coffee, have a meal, come back, and it's stacked for you. And then I'm going to talk about post-processing, which is where the fun happens. Post-processing is very much hands-on. You have to do all the work, and if you don't do it, your image won't look good. It's also the artistic part of astrophotography. Astrophotography is a combination of science or technology and art. There's definitely art involved. There's artistic decisions. So that's the fun part of post-processing. So stacking. What it is combining multiple images into a single image. Now, why would we want to do that? Well, first of all, statistically, averaging a bunch of images will remove random noise. So anytime you make a measurement, there's some random factors in there. If I want to measure a block of wood very accurately, I can take 3 measurements with 3 different tape measures, and I'll have a more accurate measurement than if I just did it once. If I want to remove randomness of my own observation, I might get a bunch of other people to make the same measurement. And you average all the measurements, and you're removing those random factors. So statistically, combining multiple images makes a lot of sense for removing that random noise. Also, this redundancy. In the old days of film, if you wanted a 30-minute exposure, you had to have the shutter open for 30 minutes. And if a plane flew by at minute 29, the whole effort was wasted. With multiple images, if you shoot 30 one-minute images and a plane flies by at minute 29, all you got to do is throw out that one image and you've still got 29 good images. So there's a big redundancy factor there. And very importantly, shorter exposures means you get less tracking error. No telescope mount will track perfectly, even with a guider on it. The guiding is not perfect. So the shorter your exposures, the more accurately your equipment will track. So by taking many shorter exposures, you get the same net effect, but with less tracking error in each one. Now, I mentioned calibration. What it does is it removes fixed pattern noise. I put noise in quotes because noise by definition is random. And what calibration is for is removing unwanted signals that are not random. So what kind of unwanted signals? Well, a camera responds not only to light, it also responds to heat. So you get a mixture, when you look at the image from the camera, you get a mixture of the light signal and the heat signal. And you don't want that heat signal. You take a picture of the night sky in summertime, it's going to look very noisy with a lot of cameras. So here's some of the examples. The thermal signal I just talked about. There's a remedy for that called dark frames. I'm not going to go into a lot of detail about how to shoot dark frames. this is just to let you know that there's a problem there that you need to calibrate out, and there's a solution called dark frames. There's also a read signal. Every time you read data from a pixel in the camera, so a portion of the signal is just the fact that you're reading it. So if the pixel collected 100 photons, maybe it'll collect, 10 photons of heat. So now it says 110. And the fact that you're reading it, it adds a few more to that. So it might say 116 for 100 photons. So there's an error in there that you want to calibrate out. That's bias frames are used to get rid of that read signal. There's also optical imperfections in your equipment, in the telescope, in the camera mount. There could be dust on your camera sensor. All of those optical imperfections will show up in your final image unless you get rid of them. And the way you get rid of them is with flat frames. Now, there's tons on the internet about darks, biases, and flat frames. So I'm not going to go into detail about how to shoot those. Just what they're there for is for removing unwanted signals, and the stacking process will give you an opportunity to include those into the processing. So here's an example of a single frame straight from the camera. As you can see, there is an object there. It turns out it's Messier 13, the same one that Dave mentioned in the introduction, but this is not my image from 2 years ago. This is from quite a few years ago. I'd only been imaging for about 6 months at the point where I took this. So it's very much a beginner's image, but at least you can see there's something there. There's not a lot there though. If I expand the contrast a bit so you can see more details, you can see some more detail. Can you see my mouse cursor there? Right there is a little galaxy that only showed up when I stretched the image. Now, this is not part of the processing. The only reason for stretching the image at this point is so you can see what's there. So I'm going to highlight this piece right here around this little galaxy, and I'm just going to blow that up on the next slide. So you can see the details, and you can see there's a ton of noise in the background of that image. It just looks like snow on an old TV set. Just nasty stuff. You don't want it in your picture. But remember, I talked about averaging. Typically, you would average 20 or 30 frames. For demonstration purposes, I'm just going to show you 3 frames. These are 3 different frames of the same portion of that image from 3 different frames. You can see each one's slightly different. The stars are not quite round in that middle one. So it's 3 different images. What happens when we average them? Oops. Okay, that's not, the software has to do a little bit of work. You can't just do a straight average. So one of the things it has to do is register the frames. With images that have stars in them, the software has a real easy time of doing that. So here's what happens when it registers and then averages them. The registration process leaves a little bit of a ragged edge around the edge there. That's just because it had to move each frame slightly to get the stars to line up. But with the stars lined up, well, we still got a bit of noise. So did we accomplish anything? Let's compare it to one of the originals. And you can see there's a lot less noise there. There's still quite a bit left, but it's not nearly as bad as a single frame. You can see the image of the galaxy. In the average version, it almost looks like a galaxy now, as opposed to just some random speckles. So that's one of the things that happens in the stacking process, and one of the reasons why we do it. But you notice the background isn't dark. Now, why not? It could be light pollution. Light pollution would have this kind of effect, except I took this under a very dark sky with very little light pollution. This is in fact thermal noise. It was a summertime image. It was a warm night, and the camera is recording heat. So that's what all that speckly stuff there is heat from the camera sensor. So what do we do about it? Well, the sensor is recording light and heat. If you put the lens cap on, you're taking a picture of just the heat because there's no light getting in. So that's what we do, and we call that a dark frame. It has very much the same kind of noise pattern, but of course there's no light coming in. And the software is able to subtract the dark frame from the average. So here's the effect. These are the original 3 images. And if you subtract the darks, you get a big improvement. There's still some noise there, but most of that thermal signal has disappeared. So that's why we do calibration of the images. And similar effects happen with the bias frames and flat frames. This is just to show you what the software is doing behind the scenes. So now, if we take these 3 images, we register them and stack them. There's one of the originals again, and here's a calibrated, registered, stacked image. So you can see a huge improvement from the original to the final version. So stacking, you take multiple frames to reduce noise. You do calibration to reduce the unwanted signals. The result is much improved, but it's not finished. So now well, we'll get to the processing in a second. I'm going to show you a quick run through of stacking an image. Let me just make sure that this works properly. Okay, so we're in GIMP now, which is Graphics Image Manipulation Program. And here is the stacked version of that Messier 13 image. So one of the first things we want to do with that is to, like I did in the first example, stretch it a bit so you can see what all is in that image. In GIMP, the useful tools are under the colors menu. So we pull down the colors menu and wait a second. Sorry about that, I just jumped ahead a bit. And I shouldn't have done that. There we go. This is what we want to be doing. We want to be doing Deep Sky Stacker. Okay, so we will open our picture files. And I'm not going to be using M13, I'm going to be using M20. So here are a bunch of frames. And to see them, you have to click on them. So Deep Sky Stacker lists all your frames down here below. You can look at each one at a time. And here's a little stretch bar. I'll give you more examples of this when we talk about post-processing. But if you slide this little slider, you can see something is starting to appear there. And this is what I referred to as stretching in the previous example. It just brightens up, changes the brightness and contrast a bit so you can see what you've got. So now you can click through the various frames, and you can see the image jumps a little bit when I do that. So each one is a different frame. And you can check for bad ones, throw out any that you don't like. Here's an interesting one. An airplane flew by while I was taking that frame. So that's one that you might want to consider throwing out, or maybe not. There's processing techniques that will get rid of satellite trails and airplane trails like that. I'm going to leave this in the stack. I've got 16 frames, I believe. I also have some dark files. So when I click on dark files, it gives me a chance to select my darks. So I open them up and it adds them down here. And you notice it identifies them. The lights are shown with the word light here on the type, and the darks are shown as dark and appropriately named. It looks basically black, it should. And to do the stacking, it's super simple. You get all your calibration frames. In this case, I did not have flats and I did not have bias frames. So all I've got is my image frames and my darks. So I'm going to do check all. You notice check mark appeared for everything here. If I wanted to leave out that one that had the satellite trail, I could just uncheck it and it won't be included. But I'm going to leave it in. And then to actually do the stacking, you click on Stack Check Pictures. Click, it gives you a little confirmation of what it's going to do. And there is one thing I want to show you on here because it's not obvious and it's very useful. If you go under Stacking Parameters, under Lights, the default is Average under stacking mode. And that's what it says. It just averages all your lights. But if you use one of these that says clipping, kappa sigma clipping or median kappa sigma clipping, the clipping process, you don't have to know how it works, but what it does is it removes defects like that satellite trail. And for those pixels that are affected by the defect, it will only use 15 instead of 16 frames. It'll just leave that one out. And all the other pixels, it will take all the data. So it's a very useful thing for removing transient effects like that. I'm going to click OK and tell it to go. And away it goes. And that takes a few minutes. Hopefully not too many because it's a fast computer. Yeah, it's right into stacking already. You can see the progress. It's up to 5 of 16 already. Not very entertaining to watch. If you have a slow computer, this is the point where you might want to go away and fix yourself a copy. But it's moving along quite quickly here. And it helps that I've done this example a few times in rehearsal because that actually speeds it up. It saves some of the information that it's been computing. So in 15 seconds or so, we should have a picture to look at. Oh. And there's our final stack picture with all the darks applied. And this is the point at which people will post on online chat forums. They'll say, well, I stacked all my images and I can hardly see anything. So remember, I warned you that was one of the questions that people ask frequently. We'll talk about that in just a second. But this is a pretty good image. There's some sliders here you can play around with. Deep Sky Stacker has very limited image editing capability. You can, in fact, slide these things around and make the image easier to see. So if I do something like that and hit apply, oh yeah, there we go. We can see more of the picture. But I really recommend leaving that stuff aside and saving that for when you're actually doing your post-processing.
Kathy, there are a couple of questions.
Okay, go ahead.
One is, what Canon camera is being used and what lens? And the second question was, would you use DSS for stacking pictures of the moon?
Both good questions. This was a Canon 350D, which is a very old model. It's astro modified, which means it's sensitive to hydrogen alpha light. The lens was my 200 millimeter f4 Newtonian telescope. So not a camera lens at all. The camera is mounted right on the telescope. The second question was,
would you use DSS for stacking pictures of the moon?
Pictures of the moon. No, you couldn't. Deep Sky Stacker, remember I talked about the registration step, getting all the frames lined up? Deep Sky Stacker needs good star images in order to do that. And if you have a picture of the moon, typically you're zoomed in, so there's no stars visible at all. Even if you were zoomed out so that there should be stars around the moon, the exposures are totally different, so the stars wouldn't be visible. And as a result, DSS cannot stack lunar or planetary images. There's different software that does that. Registax will do that. AutoStacker will do it. They're optimized for planetary images. Deep Sky Stacker is strictly for the deep sky objects. That's why it's called that, Deep Sky Stacker. So any image that has stars in it, it can stack. The stars have to be good quality. If the image is leaving trails because the tracking was off or your polar alignment was off, then it might refuse to stack with those stars. But if you have good round stars, then it'll stack anything that's got stars. Okay, carrying on. That's basically all there is to using Deep Sky Stacker. Obviously, there's a big menu here with all kinds of stuff on it, all kinds of settings. By all means, play around with that. But I've just shown you the basics. Load your images in, tell it to go, and it does its thing. So I'm going to just exit that. I don't need to save the changes because it's already saved the default version. So I'm just going to say no to that, and I don't want to save modifications. And we'll go back to, there we go. So we've done our Deep Sky Stacker example. Multiple screens here, so I need to arrange things. Okay, so moving on to post-processing. I was getting ahead of myself earlier on, but we're at the right spot now. Post-processing fiddles with things like brightness, contrast, the color, and noise reduction. Those are the important features that you want to use, you want to address in post-processing. There's obviously all kinds of stuff. There's some very powerful software out there with zillions of options. You don't need to know those when you're starting up. These are the basics that you're probably going to be most concerned with. Before we get into actually doing anything in post-processing, there's a couple of concepts that I need to talk to you about. One of them is the histogram. And all photography uses histograms. Almost every camera has an option to show you a histogram of the picture you've just taken. What is the histogram? Well, it's a graph with, on the horizontal axis, the brightness of various pixels going from black to white and everything in between. So medium brightnesses are in the middle, dark stuff is to the left with black at the extreme, light stuff is to the right with white at the extreme. And the graph that it will show you is the number of pixels at each brightness level. So this is your histogram, and people will just refer to it as a histogram. They'll assume that you know what they're talking about. So that's why I'm showing you this, so that you have an idea of what they're talking about. And when we actually get into some software and using it, one of the things that you can do with histogram tools in image software is change the white level. So there'll be a little tool, I'll show it to you when we get into the software. There'll be a little arrow over by the white end of the axis, and you can grab that tool and slide it. So if you slid it over to somewhere here, what is that doing? It's not obvious, so I'm going to show you. What that's doing is compressing the brightness range. So you still have black at the left, but now I've slid the white all the way over to here. And what does that do? Well, all those pixels that were out here are now beyond white. They're whiter than white. Well, there's nothing whiter than white, so they all end up piling up where white is. Once you've done that to an image, you cannot get that data back. You've destroyed data by doing that. So basically, too much stuff gets white if you get carried away with doing that. You can do it a little bit. It doesn't matter if, 1/100th of 1% of your pixels are white when they shouldn't be. Nobody's going to notice. But if you get carried away with that, it's called clipping, and it's not good. So it's something to avoid. The same can happen at the black end. If you drag the black slider over, you would be clipping the black side as well. So those are two concepts that you probably should be familiar with in image processing, the histogram and what happens when you clip. So taking a real example, M13. This image was taken in 2011 in May. I'd been imaging for about maybe 6 months at that point. The pictures were taken with a Pentax camera. It's an old model now. It was fairly new at the time. Using my 8-inch Newtonian. And it was on an HEQ5 mount, which is quite a decent mount. A little bit small for that particular telescope. And important to note, it was unguided. So you don't have to have a guider to take half-decent images. I was taking 18 frames of 60 seconds each. And when I stacked them, I didn't use any of those calibration frames. I just told you should do it. I was a beginner. I thought, no, I'll just see what I can get. So I took some light frames with no calibration image at all. So what did we end up with? Okay, now I was going to go to GIMP to take a look at that. There we go. So this is what happens when you stack a bunch of those frames of M13. You saw this image earlier on. There's obviously more to it than that. In fact, the globular cluster comes all the way out to about 3 or 4 times what you see here. So how do we get that? Well, under the colors menu in GIMP, there's something called levels. They call it levels. What it is, in fact, is the histogram tool that I just told you about. So here is that histogram graph, like I showed you a couple of slides ago. There's the little slider at the white end, where I can start clipping pixels if I really want to do that. There's a slider at the black end. I can flip the other way if I really want to do that. I don't want to do either of those things. There's a slider in the middle that will skew the data one way or the other. See what happens when I do that? It's lightening everything up. And that's called stretching the image. At this point in the processing, you want to do just a real basic stretch, just so you can see what's there. And you notice when I did that, go back to the way it was, all of a sudden, that globular cluster got quite a bit bigger because there's dimmer stars that are now visible on the screen. So that's one of the first things you want to do when you're processing is play around with the histogram tool, whatever it's called in your software. Some software calls it histogram, some software calls it levels like this. But that's just a basic stretch so you can see what you're dealing with. Oh, this is interesting. Keep that. Okay. Yeah. Gotta remember to click OK.
Kathy,
So there's, yes?
sorry, We're correct in thinking that when you said unguided node, you weren't tracking M13 at this point to take these.
I was tracking it, but I wasn't using a guider. So there's no guide scope, there's no guide camera. It's just a dumb motor driving them out at a predetermined speed.
Thank you.
Okay, so here's a stretched image. Obviously, the background is too light. Colors don't seem to be too bad, but they're a little bit washed out. So let's see what else we can do. One of the most useful tools that's in almost every image processing software is the curves tool. And that, it gives you a version of the histogram. You can actually see a spike here in the background of the graph. That is your histogram, that grayscale. The reason it's a peak is because almost all the pixels in this image are at about the same brightness. That's your background. So that peak in the histogram is almost always going to be your background. And you notice it's quite a ways off the black side. It's well into the mid-grays, as you can see. It's just telling me that the background is too light. So that's okay. We can at least see what we're dealing with. And one of the first things I want to do, especially with a globular cluster, is try to bring out all the stars. Now I can make everything bright by grabbing the straight line and dragging it up. What you're actually looking at on the graph is the horizontal axis is the before brightness, and the vertical axis is the after brightness. So by dragging it up, I've taken pixels that were medium gray and have made them very pale gray. So I can get much finer control using the curves tool than I could with the histogram or levels tool. Now, one of the first things I want to do is make things brighter, but look what's happening in the center there. It may depend on your monitor, but I'm starting to wash out details in the center. So that's too bright already. So how do we control that? Well, I don't want the bright pixels to be made brighter. I'll just take them back down. And you can see why they call this a curves tool. I don't really want the mid-range to be too much brighter. I want the background to be dimmer. And you see the background is getting dimmer without affecting in here. Now this is still too bright because I was doing a demonstration here, so I'm going to reset. What I'll normally do is start by taking the background down. And I've lost some of my outer stars. So I'll bring the mid-range back up, and that brings them back in again. And I don't want the bright stars in the middle to get washed out, so I'll keep them down a bit. And we'll try that. Yeah, looking better already. And I go back into it and do more processing. The reason I'm doing that instead of doing it all at once is because it's very hard to do it all at once. You're much better off to make a bunch of small changes rather than do one great big change. So one of the beginner mistakes people make is trying to do it all too quickly. This takes time, so just keep hitting the curves tool one step at a time, make a little adjustment at a time. You notice, by the way, this peak showing where the background is has moved to the left since the last time I went into the curves tool. That's because I made the background dimmer. So we'll do some more of that because it's still too light. And I tend to pull down the dark side of the peak. So here's my peak. It's centered at about 25%. I'm pulling down at about 15%. It's easier to control the background that way. Some of the stuff at the right-hand toe of that histogram is usually nebula or stars or galaxies or the good stuff. Right in here is where you find the good stuff. So let's turn the good stuff up a little bit. Yeah, there's my Plus they're getting a bit brighter. The center is still getting a bit too bright, so I'm going to take the bright stars down a bit. And we just keep doing that a bunch of times until we're happy with the image. Anything else I can do with this? Not really. I think the brightness is about where I want it. I can maybe take the background down a little bit more. Now, how about color? There's some color there. You can tell that star is bluer than that star, but it's still kind of washed out. And the tool for that is called saturation. In almost every image, you're going to have to boost the saturation. So I'm just going to take this control and crank it up a bunch. And that's better already. You're starting to see some blue in there. And again, it's good to hit this in several small iterations rather than all at once. Particularly with saturation, it's possible to go way overboard and you get something that looks totally gaudy and not presentable. But now I'm starting to get better appreciation of the colors. It's kind of greenish on my monitor. So how can we adjust that? There's a bunch of tools. You can go into color balance. You can do hue and saturation. What I like to do is go into curves. Curves is by far my favorite tool because if you look up here, we can select green. So now, if I drag the curves around, I'll be affecting just the green, nothing else. So I'll just grab it in the middle and turn green. Oh, too far. It's already going purple. So you can see it's very sensitive, especially when you're balancing color. You make tiny, tiny adjustments. That's about as far as I want to go. Not a very big adjustment at all. And I click OK. And that's an image that I'd be happy to spend some time looking at. So we can save that and we get ourselves an image. Actually, I'm not going to bother saving it because I've already done that. So that's just the basics. Brightness, a little bit of color twiddling. Any questions about the most basic manipulation in a graphics program?
Just a reminder that if you want to ask questions, two ways. One is either to unmute your speaker, and the other is to put them into the chat, and we can ask for them there. And there is a question on the chat. It says, was the camera Astromod, and where you click the picture portal scale?
I didn't quite hear all of that, Judy. The camera was Astro modified.
Okay.
Actually, no, sorry. This example, the camera was not Astro modified. Subsequent examples, it was. This was a different camera. This is my Pentax that I use for shooting vacation pictures. So a very early attempt of mine, and I quickly decided I wanted some more capability. But that's one reason why I used a very early image, was to show you what can be done with very basic equipment. Sorry, what was the second part of that question, Judy?
I'm not quite, I don't completely understand, maybe you do. And where you click the picture, and then she's got in brackets, or he or she has got portal scale.
Oh, Bortle scale. This site was about a Bortle 2, I believe. So a pretty good dark sky. Might have been a 3 on a bad night, but a very good dark sky. So I didn't have a lot of light pollution to deal with at all. And it's worth getting to a dark site to get the good data.
Okay, and can you remove the color noise that has re-emerged in the final image of M13?
There are noise reduction tools under filters, enhance, noise reduction. Now, this particular software, GIMP, is meant for editing vacation pictures. It's not specifically aimed at astrophotography, so it has very limited noise reduction tools. But yes, I can do noise reduction. I can adjust the strength. Let's crank it way up there. You don't want to crank it, the noise reduction up too high, or you'll lose detail. It'll start to blur things. But it does a little bit of noise reduction. If you want really good noise reduction, then you're going to have to go to software that's specifically aimed at astrophotography. So PixInsight has some very good noise reductions. I know there's a lot of other software packages that people use. Anything that's designed for astrophotography will have better noise reduction than this one does. But it does have a basic noise reduction tool, and it kind of works a little bit.
Okay, and where can you get the Astro modification done, or did you do it yourself?
I don't know, and that's kind of out of the scope of this presentation. I'm assuming that you're going to be able to take pictures, and this is really what to do with them once you get them onto the computer. So there are places that will do modification, and you can do it yourself. There's instructions online, but that's all way over my head. I just scanned the classifieds to find a camera that somebody was selling that was already modified. Okay, so we've done the M13 example. And just to give you a sample, there was the before, straight out of Deep Sky Stacker. This is not the example I just did, but it's very similar because I'm doing the same steps. This is what you can end up with. So quite an improvement. You see a lot more detail from the original picture once you've done the processing. How are we doing for time here?
Aditya, you
time for one more example.
unmuted. Did you have a question?
No, I don't have a question. I was being requested to be unmuted.
Ah. Okay.
So carrying on with the second example, this is M20, the Trifid Nebula, also taken in 2011. So by this time I had a couple more months of experience. I had switched to the Canon 350D, which is astro modified. I didn't do the modification. I bought it secondhand, already modified. Same telescope as before, my 8-inch Newtonian, same mount, but by this time I've added a guide scope and guide camera to it. So hopefully my stars will be a little bit rounder. I'm still shooting 1-minute frames, and I'm still shooting 16. So not a whole lot. You can easily shoot a lot more on any deep sky target. One big difference, I've added darks to my process now. I still haven't started using flats or biases, but darks make a difference, especially with a camera that old. It's really important to shoot darks, as I discovered. So let's go and pick up that example. There we go.
Okay, so while you're getting your example,
So,
there's a couple of things.
okay.
One was, they said, great presentation. A question for you. What software did you mention for moon and planet pictures?
Registax is one of the most common. Registax with an X on the end. There's also one called AutoStackert. I find that one a little bit easier to use than Registax. Both of those are designed for planetary images. So they will register based on textures in the picture. So, you know, a particular crater on the moon, for example. You identify which feature you want it to register on, and pick 3 or 4 of those, and it will then register your images based on that, which is a totally different technique than Deep Sky Stacker uses.
Okay, and what ISO setting
Okay,
for the 1-minute
carrying on.
exposures?
Pardon?
What ISO setting do you use on the 1-minute exposures?
I believe I was using 800 on both the M13 and the M20 example. So here we are with a nice picture of the Trifid Nebula, and you can't see a darn thing, right? So I'm going to do the same thing I did before. I'm going to go into levels, and I'm going to drag that middle slider over to lighten up the mid-range. And now I can see the direct. You can tell I don't use this software quite as often as some others. Let's try it again. And this time, remember to click OK. There we go. So now you can actually see the nebula there. But we can also see the background is not just light, it's also kind of red. And the reason for that is because it was a modified camera. The hydrogen alpha modification lets through a lot more red light and messes up with the camera's color balance. So this is typical for a modified camera. So first of all, let's make that nebula a little bit more visible. Going to my favorite tool, curves. And you can see here's the peak from the background. It's well up towards the mid-range because I just wanted to see what was there. So I'm going to place a point right there in the middle so I don't mess up the right-hand side of the graph. And I'm going to drag the left side down, darken the background. Now that's an improvement. And now we're going to brighten up the brighter stuff. Now notice what happens when I move this data point in the bright side of the graph. There's not a lot happening, right? That's because the stars are already bright. So what's up here is just stars. And it's very useful to figure out what parts of the graph correspond to what parts of your image. So now that I know that the stars are up in this range, I can just say, yeah, I'm happy with the stars. I'll place a data point there to leave it there and leave that altogether. Down here, I know I'm dealing with background because I can see the background change when I move that. And that means this little toe on the histogram is my nebula. So we'll take this and slide it up. There's my nebula getting brighter, or I could make it darker. So you see what I've done there is I've identified where on the graph the features of the image are. And that's very useful for making small adjustments. I'll go back into it. You notice my peak has moved to the left because I dimmed the background. I'm going to do that some more because that background is way too bright. And that also dimmed my nebula, so I'll just bring it back up again. You can see how that toe has broadened out as well because I brightened the nebula. And we'll OK that. Now you're probably thinking that's just a little bit gaudy. And you're right, it is. Because in this case, the saturation is a bit too high. Let me just turn it down some. It's still too red, but it's not quite as gaudy. So what did we do about the red? And again, like I mentioned in the previous example, you can play with color balance, but I like to do that with curves. And we'll just go and select the red channel. And it's mostly background that's too red. So let's just turn down some of the background. And it becomes less red. Meanwhile, the stars, which are not red, and they're also bright, are not being affected much at all. So that's good. My nebula is looking a bit more reasonable. Now, I know that this part of the nebula should be blue because I've seen lots of other people's pictures of this. So I could play around with that by selecting the blue channel and turning it up a little bit. And you notice what's happening? Not a lot. The stars are getting bluer. I don't want that. Let's bring the bright stuff down. But not a lot happening on the nebula. And if I get too carried away, it all goes purple. So in this case, I just have to accept the fact there's not a lot of blue data there. The sensitivity of my camera just did not pick up on the blue. It was washed out by the red from the hydrogen modification. So you win some, you lose some. I'm going to turn the background down some more. Let's get a bit better. Now, I could spend all night playing with the color. I'm not going to bother because it's just going to take up time. And this data is not that great to begin with. It was an early attempt, and one of my first attempts with that camera. I was getting used to it. So I'm not going to waste time fiddling with it. But you can see how you can fiddle with it. I've adjusted the color quite a bit. I've adjusted the contrast. I probably want to do a quick pass at noise reduction. Let's enhance noise reduction. Yeah, put a bunch of noise reduction. And if I decide that's close enough, I could save that image. Just gonna switch back here. And the one on the right, it's the same image. Obviously, I played a lot more with the blue, got kind of carried away with it, and the whole image is blue. But basically, I went from that on the left, out of the sky stacker, to this, which is at least something recognizable. So that's kind of the process of post-processing. Judy, how are we doing for time? I've got another example. It's kind of more of the same, shows a little bit different techniques on a different image. But if we're going over time, I can cut it short at this point if you want.
We are running a little over time, but
Okay.
how long do you think it would take, Kathy?
Probably another 5 or 10 minutes to do that example.
Well, we could certainly do it, and if people would like to leave at this point in the discussion, they can. Otherwise, we'll continue.
Okay, let's go for it. So the third example.
Somebody has already said yes, continue.
Okay, we shall do it. NGC 7023 is also known as the Iris Nebula. This was taken about a year after the M20 image, so I would hope that my technique is a little better by this point, but still quite an old image. Using the same camera, the Canon 350D, same equipment basically. Big difference is I'm shooting a lot more data. I'm up to 4.5 hours of total data. Frames at 5 minutes and 10 minutes. And I'm still only shooting darks. I never did get around to doing flats or bias frames in some of these early images. And you can get away with that if you're careful. So let's process that in GIMP and see what we get. So there is how it came out of Deep Sky Stacker. You can tell there's some. No, because this is a color camera. So it's basically a vacation pictures camera that's been modified with to be sensitive to hydrogen alpha light, but no filters at all. So you can see there's something blue and bright in the middle, but you can't quite tell what it is. So again, let's do that initial stretch. Okay, there we go. And you'll see that I've got some registration artifacts here. That's because my 4.5 hours was taken over 3 different nights, and the frames don't quite line up exactly. That's okay. We'll just crop them out. So I need a crop tool. Where is that? Okay, there's my toolbox. And I'll start down in this corner because that way I can see when it's centered. There, that looks pretty centered. Image, crop to selection. Okay, we've cropped those ragged edges off. And that's something you'll frequently have to do with stacked images. Ragged edges are very common, and cropping is just a normal part of the processing. So let's go into curves and see if we can get a bit more detail. There's some really juicy detail on this target, so if you decide to go for it, have fun with it, because all this dark area is good stuff. You want to be able to see that. But first of all, I need to bring the background down quite a bit. And I'm going to bring remember the nebula lives on this little toe of the histogram. So I'm going to bring that part up. And now you're starting to see some stuff. You can see we've got kind of clouds around here. You can see there's a little porthole in that cloud. That's a really cool feature. If you do this target, you really want to bring that out because it just looks so nifty. And we'll try it again. More of the same.
Can
Yes?
you use CLS, CCD, and filter with astro modification camera in Bortle 7 or 8 to click good frames?
I haven't tried it because I've been fortunate to have good dark skies wherever I've been imaging. But people do it, and if you've got a terrible light pollution, some kind of filter is probably a good idea. But again, this is more about processing rather than capturing the images. So that would be a different presentation. So now by repeating the same stretch that I did before, I'm bringing the background down and the nebula up. We're starting to see some more detail. We're also starting to see some nasty colors. So let's go back in and turn some of that green down. And I know from seeing other people's versions of this target that it's mostly blue with a little hint of pink in the middle, and these clouds actually should be brown. So I've got a little bit of work to do yet on color, but let's keep bringing out those details. And again, we want to see where on the graph the various features are. We know the stars are bright, so they're up there. You know, we don't need to play much with them. We'll just leave that pinned where it is. We know the background is dark, but we want to be careful not to darken it too much because there's those very nice dust clouds. So I'm going to bring up some of the dust clouds. And they're still looking kind of green, but at least you can see them. And I've got some funky color happening off on the right-hand side here. That's where flat frames would have helped me, but I was still new at this, so I wasn't taking flat frames. There are ways you can process after the fact to deal with stuff like that, but that's not beginner level stuff, so I'm not going to get into that here. Let's reduce that green some more. Now I don't want to reduce the really dark stuff because that isn't green. It's the mid-range stuff that's green, so I'm going to pull it down there. Oh, too much. And I want purple. And I can actually put some green back in the dark corner. And I might want a little bit of red in there to balance out the green. And again, you want to be very subtle with color adjustments. Otherwise, you can wreck the whole thing. So if I go any further with that, it's probably going to make a mess of it. With the data that I've got, that's about as good as you can get. I like to make sure that little window in the dust cloud is there because it's just so cool. You're actually seeing a cloud of dust that all this area is dust. But right there's a little porthole through the dust. You can see the stars behind it. And that is so cool. I like to make sure that's visible. Anyway, that's about all I think I can do in the time available with this image. Except I might just turn the saturation down because I got a bit carried away on the color. That's a little more reasonable. And then I would save that. There we go. So we've done a third example of processing. And for the slide, when I did the example, I spent a bit more time on it. Still got a bit carried away. and it came out a little bit too contrasty and a little bit too saturated, but you get the idea. And that, I think, is it. So if there's more questions, particularly about processing rather than equipment, we can talk about that. Otherwise, I think I'm done with the presentation.
Well, thanks very much, Kathy. That was really very good. I've dabbled in this a bit, but I find it very confusing at times, and you've managed to clarify a lot of the steps in the process and how people can get started, at least. And it's always interesting to see how it's done. You know, they say that lots of people like eating sausages, but they can't stand watching them being made. So
yes,
one often wonders about images, because when I was first playing around with this and I was trying to get a picture of the dumbbell nebula, and I was trying to see how good I was at you know, getting it right, and I went online and every picture of the dumbbell nebula I saw looked completely different. And then I realized that really when you get to this part of the process, it really is an art rather than a science, because there's no correct way of doing it. It's kind of how you see it and what you like to emphasize. So it's an interesting process. So I've noticed that we had almost entirely the way through, we had up to about 60 or 61 participants, and we still have 55.
Oh, wow.
So you've kept everybody pretty much from when we tuned in. You've kept everybody enraptured with your presentation, and that's pretty good going, I think, because sometimes you find people drift off. So congratulations for keeping everyone's attention, and it's you know, I guess it's a testimony to how clear your presentation was and how useful it was to them. Thank you very much.
Yeah, thank you,
You're
Kathy,
quite welcome. Thank you.
and to Dave for moderating this for us. I want to thank all of you from coast to coast, from Victoria all the way to St. John's, Newfoundland. Welcome, and hopefully we'll see you next week on August 11th at the same time, when David Hoskin will address Lucky Imaging, Astrophotography of the Moon and Planets, where he'll describe the technique used to capture high resolution images. So it's a follow-up to Kathy's. She gave us a great introduction, and Dave will build on that. And a reminder.
And if I may interrupt there, just that's one reason why I avoided doing any planetary or lunar image examples in this one, because I knew Dave was going to be doing it next week.
Good plan, yes. And there was a question earlier, and I will remind everyone, because this is being recorded, we will be posting this on YouTube, and you go to YouTube and search for Rask Halifax, and you'll find our channel there, and you'll see all the videos, including this one, and all subsequent sessions as well. So thank you, everyone, and we will see you next week, hopefully. Thank you very much.
Thanks, Judy.
Thank you.